Welcome! In this explainer, we're going to move past the basic chemical ranges you find in textbooks. We're going to dive deep into those real-world pool problems that can leave even the most seasoned pros just scratching their heads. So let's start with a question that I know every single pool professional out there has asked at some point. You've done everything by the book, your test kit is telling you all the levels are fine, but that water is still cloudy. Or the chlorine just won't hold. Or there's that stubborn bit of algae that just refuses to quit. You just gotta wonder, what is really going on? Well, today we're gonna put on our detective hats. We're gonna start by going beyond the textbook. Then we'll investigate something I call the conditioner conundrum and uncover alkalinity's hidden truth. After that, we are going to hunt for some invisible chlorine thieves. And finally, we'll go from just guessing to actually knowing. So our investigation really begins with admitting a simple fact. The real world, it's messy. You know, those basic guides you find online or on the side of a bucket? They're a decent start, for sure, but they definitely don't tell the whole story. Yeah, those guides will get you maybe 70% of the way there. We're here to talk about that other 30%. You know, understanding the tricky parts, the chemical interactions that cause all those frustrating, why is this happening to me kind of problems. All right, so when a pool just won't hold chlorine, our number one suspect is often the conditioner. You know it as cyanuric acid, or CYA. And yeah, we all know it's supposed to protect chlorine from the sun, but it has this secret life that can cause a whole lot of trouble. And this is a great way to think about it. Think of conditioner like a parent. A little bit is great, right? It protects the chlorine from the sun, but too much of it, which, let's be honest, happens all the time when you're just using tablets, and it becomes this overprotective parent, hugging the chlorine so tightly that it literally can't do its job anymore. So to get around that overprotective hug, we've got to use a simple but really powerful tool. It's called the 7.5% rule. This little bit of math tells you the minimum effective chlorine level you need based entirely on your conditioner reading. Let's use a super common real-world example. You test a pool and the conditioner, the CYA, is at 100 parts per million. I mean, this happens constantly, especially in pools that get a lot of chlorine tablets. So we take that 100 ppm and we apply our rule. We just multiply it by 7.5%. The math itself is super simple, but trust me, this is the key that unlocks the whole problem. And there's our answer. 7.5 parts per million, that is the absolute minimum level of free chlorine you need in that pool for it to actually be sanitized. Now think about it. That is way higher than the standard 3 to 5 ppm you read online, right? And it totally explains why a pool can have 4 ppm of chlorine and still be turning green. Okay, so here's where it gets even crazier. Our first suspect, conditioner, it doesn't work alone. Nope, it's got an accomplice that is totally messing with another critical reading in your test kit, your total alkalinity. I'm not kidding. That number you see on your test strip, it could be a complete illusion. And why is that? Well, because conditioner is technically cyanuric acid. It's an acid. So your alkalinity test actually counts it, and that artificially bumps up the result, making you think everything's fine when it isn't. But hey, don't worry, we can see right through this illusion. There's another pretty simple formula for it. First, just take your CYA reading and divide it by 3, okay? Then you take that result and you subtract it from whatever your test kit said the total alkalinity was. Whatever's left over, that is your true alkalinity. So let's look at the impact here. In our pool with 100 ppm of CYA, your test kit says your alkalinity is a perfect 100. But once you do the math, your true alkalinity is only 67. That is dangerously low, and it means the water is way more corrosive and aggressive than you realize. So you've mastered the 7.5% rule, you're calculating your true alkalinity, but what if your chlorine is still disappearing into thin air? Well, now it's time to hunt for some invisible saboteurs. If you're seeing any of these symptoms, you are probably dealing with unseen contaminants. The chlorine you're adding is being eaten up almost as fast as you can pour it in because it's fighting a battle that you can't even see. The two main culprits here are usually phosphates and nitrates. Just think of these things as an all-you-can-eat buffet for algae. They create this perfect environment for algae to just thrive, and your chlorine is constantly being used up trying to fight it. That's what we call high chlorine demand. Now, it's absolutely critical to know which one of these you're dealing with. Phosphates, they're pretty common, and you can treat them with a remover. Nitrates, on the other hand, well, They're a much bigger problem. There is no chemical fix for nitrates. The only solution is to drain some or all of the water out of the pool. Okay, let's bring all our clues together. By moving beyond just the basic rulebook, you can actually investigate a problem pool like a pro. And you know what? This is what separates a good technician from a true expert. So this is your new advanced toolkit. When chlorine seems like it's not working, you've got the 7.5% rule. When the pH is bouncing all over the place, even with good alkalinity, you calculate the total adjusted alkalinity. And for those really stubborn problems, you test for phosphates and nitrates. You're not just guessing anymore, you're actually diagnosing. And really, that's the goal, isn't it? This kind of knowledge empowers you to understand the why behind the problem. You can walk up to any pool and confidently explain what's happening, take control of the situation, and make sure that pool is safe and clear every single time. So we'll leave you with this final thought. The absolute best professionals, they never stop questioning the rules. Because out here in the real world, it's understanding the exceptions that truly makes you the expert.